Hi, everyone, and thank you for having me. And I'm part of your camp. I'm Morteza from Stockholm School of Economics, Finance Department, and I'm going to talk about my working paper. And I'm really sorry that I'm not there, but hopefully I'll meet you somewhere else in other conferences. I mean, in this conference, I think we don't need to provide any uh, motivation or reasoning for that. The climate change and climate crisis is important. And until now, we have lots of different papers where we talked about the effectiveness and the consequences of the climate change. And because of the importance of the climate change, most of the governments try to intervene in the markets, and they implemented different types of policies, carbon pricing, subsidies for firms to provide incentive for their act toward the emission controls. And the economic impact of these policies has been widely debated, and it's really important to investigate when we talk about acts against climate change, what are the costs that we are paying for that. Before going further, I want to provide a framing that I think that's how I see the problem, and I want to tell that how does my work related to this framework. The first part is that, okay, we have three different policies or three different ways that we can reduce emission in the economies. The first is that, okay, we keep the same production structure. We just use the abatement technology to reduce the emissions. For example, companies, they have to stick to their production structure, just they need to implement some filtration, some ways to absorb the emitted carbon during the production process. The second approach is that, okay, we just changed the energy that they use, substitute from brown energy to green energy, which we can see everywhere in the electric cars. Instead of using gasoline, we are using electricity to move our cars. And the third approach is that moving the production structure, moving toward the green production structure, which I call it green capital. And a common example in this context is a steel company, which it's not easy to only use, for example, solar panels or something like that for producing energy. They need to find a new procedure for having a green steel. They cannot just move toward the different energy sources or use abatement technology. This paper is focused on the third approach, which is this transition from green structure or brown capital to the green capital or green production structure. And my research question would be, okay, how hard is it to move from brown production to green production? And after that, given this transition and estimation of this elasticity of substitution, then how effective is carbon policies and different instruments? How can we use these different instruments? And the related literature would be first is to quantify this elasticity of substitution between green and brown capital instead of energy. Most of the papers that I've seen, they calculate the elasticity between brown, dirty, and clean energy. This paper is going to provide the new estimates of the elasticity of substitution between green and brown production rather than energy only, and also other types of papers that they investigate the effectiveness of different policies, and I'm going to talk about that in the follow on the paper. And just a preview of the results, I'm going to use a structural estimation and working with the Swedish data to answer these questions. So my background, my data is from Sweden, and my country of study is Sweden. And my result is that the first green capital is less important or less productive in the production function, which makes sense. Otherwise, most of the firms, they already switched to the green capital. But another important result is that green capital is equally important in the green and brown sectors. The productivity of green capital is not different for brown and green sectors. But the main point is that in the brown sectors, the elasticity of substitution is lower, or brown capital is harder to substitute in the brown sectors. And also there is a positive correlation between TFP and emission technology, and the carbon taxation is the main driver of the reduction in the emissions that we can see in Sweden. The structure of my presentation would be first, I just present my model. I mean, very big picture of the model, because I have two minor extensions to the SCHIC Illinois 2009, which make it feasible for me to use that model in this framework, and then talking about data and institutional background in Sweden, and then estimation and counterfactuals that we have. As I mentioned, my model is based on SCHIC Illinois 2009. And we have it's a standard framework. We have heterogeneous monopolistic competitive firms, Cobb-Douglas production function, and CS aggregator for outputs. My extension is that instead of one type of capital that we have, there is a message, sorry. Oh, yes, okay. I tried to finish earlier. Two types of capital we have in the production process, green and brown capital, as I mentioned, and also I augment the model with the emission production function, which is a new part of the model. And then at this version, I have these assumptions that we have exogenous technology changes for emission and for TFP or productivity, which means that firms, they do not invest in their R&D or any types of changes in the technology is exogenous. They born with the technology, and there is a process for that, but they cannot affect their own technology by their own choice. And there is no adjustment cost for the capital, and it's partial equilibrium in this version. As I mentioned, I'm using Cobb-Douglas production function. We have firm I in industry S, which produce YI. They have for TFP a hat, and they use K hat, which is capital, and labor as a typical Cobb-Douglas production function. But the K hat that we usually have in the Cobb-Douglas production function in this version is a combination of the green and brown capital. It's a simple aggregation where alpha S is the importance of the green capital and gamma S is the elasticity of substitution between green and brown capital. And you can see all the parameters that I have. Alpha S, all of the parameters that they related to the production function, it's related to the industry level. So for each industry, I will use the same production function, but they have different idiosyncratic productivity, which makes them difference in their own production industry or industry that they are active in. And another new part of the model is that we have this simple production function for the emission, which is a tilde or emission technology or emission intensity times the brown capital. And the difference between brown and green capital is here, where brown capital is the only contributor to the emission function or leads to the emission in the production process. And given this simple extension, then firms' optimization problem would be, as always, not always, but they try to maximize their profit. They have revenue minus the cost of production that they usually have. I take the demand function as given. It's monopolistic competitive firm. There's a markup that they charge, and interest rate and wage is exogenously set, and they don't have any power on that as well. As we care in this setting, governments, they implement the tax tau E over each industry, which firms need to pay taxation over the emission that they have. And also it's possible that we provide subsidy for green capital or ESG preferences of the financier or whoever lend money to these firms, which makes the interest rate for the green capital different than brown capital. Given this simple extension, then this optimization problem for the firm is straightforward. It's simple. These two extension is very simple, and then we can add up the model and aggregate everything. And I'll skip this part, go for the data, the institutional background, and the estimation process that I have, and then talk about the results. As I mentioned, I'm using Sweden. Sweden was one of the first countries that implement carbon taxation from early 90s. At that time, it was over only Scope 1 emissions from fossil fuels that has been used in the combustion engines and heatings, and some ideas that, okay, why Sweden was one of the early adopters. The first reason I think is that they don't have that much fossil fuel resources, and also there is no significant anti-climate lobbying in Sweden. And on the other hand, they have a strong public support for climate action. And probably you all know about Greta, which she is Sweden, and she's just a representative of a great number of people that they are active here for uh, per, for persuading governments to do something for the climate change. And also another economic reason that we have that in Sweden from early 90s, the most part of their electricity has been produced from green resources. So the transition toward the green electricity, it was easier for them because they already have it. And then if you just want to know about the taxations, it started from 91. It started around 200 SEK per ton of CO2, which I think at that time, I think Per knows better. At that time, it means around 20 euros per ton of CO2, and it was almost constant during this time. And in the last, after 2015, there is a jump in the tax rate, which in this study, I'm only using 91 to 2015. So the tax rate's almost constant over the period. And also, if you want to know about the effectiveness of this taxation, you can see the emission intensity total emission over total sale has been halved during this period, which suggests that this policy was successful. And my data is from Per's paper, Martinson et al. 2024, which they have public and private firm. They match the CO2 plant and firm level data with the firm identifiers. But there is a problem. I think this problem is for all these kind of studies, that we have the most around 90% of total emission in the Sweden, which it contains most of the polluters, but we are missing 10% of the emissions, where I mean that's that's the best we could have. But the main point is that we have public and private firms, and also we have investment data, which we can identify between green investment and brown investments, and the abatement investment that they usually do, which helps us to define this green capital variable, which is the environmental investment and all the prevention related costs that they do. I know this is not the best definition that we could have in the newer ongoing version. I'm going to exclude the prevention related operating costs to see how the results change. And the definition of the brown capital then is the total firm's investment minus the green capital, all the investments that is not related to the environmental activity I classified as a brown capital. And if you want to see how is the time trend, we have the data from 2002, and you can see the ratio between green to brown investment has been increased during this time, which suggests that the channel that firms try to reduce their emission is to use this transition from brown capital to green capital. And I mean, this is my data or institutional background that I have. Then for the estimation, I'm going to use a simulated method of moment to estimate the parameters. As I mentioned earlier, all the production function and all the characteristics are defined over two-digit industries. So my production function and all of my estimation will be over two-digit industries. I have this assumption at this version that the technology process with the technology at the first state, but there is a AR1 process for each technology around the mean of the firm's technology, which is growing at each time at a constant rate. All of these persistency rho hat and rho zero, the growth rate, will be estimated in the model. I have the same process for both technologies, but of course the parameters are different, but the structure of the parameter are the same. Let's talk about the moments that I'm trying to use to estimate the model. The ratio between green and brown capital will help me to identify the importance of the green capital. The regression coefficient from Martinson et al. Paper, where they regress the changes in the emission intensity over the changes over the cost share of the emission. I have that as this helps me to identify the elasticity of substitution between green to brown capital, because if this relation is higher, then it was more transit. It was easier for them to move from brown capital to green capital, and the other variables that we have usually for the beta or the importance of the capital, I have labor to capital, and for the elasticity of substitution between products, I have the labor wage to sale ratios. And these are the key variables that I have in my estimations, and there are more technology parameters that I have, but for the sake of time, I skip all of them. Then, given this estimation, these moments that I use, these are my model fits. As you can see, from 90 to 2015, we have in the data around 39% change in the emission, which my simulation, it's fairly close to all of the changes that we could see. I have some measurement in the sales, but it's fairly close, and which makes me happy to continue and present you the results about estimations and what are the counterfactuals that I want to. I mean, as I mentioned, my model is static, and that's why my time series, I mean, I don't care about time series, but the time series, it doesn't fit that much, or it's not that good fit, but in the updated versions, I'm trying to fix all of these problems. Hopefully, until now, I could satisfy all your concerns, and now we have the estimated model which has a good fit. So let's see what are the estimation results and how can we see the differences between different sectors. As I mentioned, alpha S is the importance of the green capital in the production function, and as we expected, the importance of the green capital is less than half, which means that green capital is almost 3 times, brown capital has 3 times more productivity or more importance in the production function. But the main point is that between green and brown sectors, the D7 to D10 and D1 to D3, the importance of the green capital is not that different. Significantly, they are close to each other, but the main point is that the elasticity of substitution, or the gamma S minus gamma over gamma S, is lower in the brown sectors, which means that the brown capital is harder to substitute in the brown sectors, as I mentioned earlier. And just for you to get an idea of what are the estimated usually numbers in the macro literature for this elasticity of substitution between green energy and brown energy is around 0.9293, which this suggests that the elasticity of substitution that we usually assumed in other models and other papers, it's roughly correct, but there is a heterogeneity between different sectors, which we need to account for this heterogeneity between different sectors that we have in the economy. And another result is that there is a positive correlation between emission technology and TFP, which means that the more productive firms, they are the one that they have higher emission intensity, or their emission technology is more polluting than the less productive firms. And this is also true within and between industries. I mean, for between industries, it makes sense if you are highly productive in a brown sector, so probably you have a higher emission intensity, but this is also true for within industry, which means that within the brown sectors, even or within green sectors, the more productive firms, they have higher emission intensity. Given these estimation results, then we can go forward and calculate or decompose the different channels that we have for the emission drop that we had during this time. As I mentioned earlier, we have around 40% drop in the total emission from 90 to 2015. And as I mentioned, if my model is static, so if we didn't change anything from 90, CO2 intensity at 2015 would be exactly the same as 90, and there is no emission change and sales change. Nothing has changed, so there is no change in the outcomes. And if we only allow for the change in the policy or we only implement the taxation, you can see the CO2 intensity has been halved and the emission change is around 55% in the economy. And the cost of this policy is only 4% of drop in the sales that we have in the economy. But the main point is that here we have the same technology as 90s. There is no change in the productivity. Firms didn't become productive, and also there is no change in the emission technology. Now, if we allow for the change in the TFP or total factor of productivity, then firms become more productive. They are producing more, so they need to emit more because their production has increased. So the emission change would come back to positive 10%. But you can see there is a sale change because they become productive, and that's how the total income has increased because they are more productive. And at the same time, if we allow for the changes in the emission technology, then we can get the numbers that we had when we talked about the model fit. And this decomposition suggests that the first carbon taxation was the main driver of the emission reduction that we had. And another result that we can see from this decomposition is that these two technology processes, they almost cancel out each other's emission effect, but the effect on the total sale is significantly high, which suggests that firms during this time, firms try to increase their productivity, and at the same time they use the cleaner technologies to deal with the taxation and all of the implications that they have after the policy. And after this, then we have this target or goal in Sweden, where until 2040 they need to reduce emission 55%. And if we are going to continue the current policy that we have at 2015, you can see until 2040 from 90, we have around 45% drop in the total emission, which suggests that we cannot achieve the Parliament's goal until 2040. And for achieving that goal, we need 5 times higher taxation, which means 3 SEK per ton. And and you can see the cost of this increase for the in the taxation is around we will lose 3% in the total sales, and in the total output around 5%. But then the key question would be, okay, what if instead of taxation, we are going to provide subsidy for the green capital and reduce the cost of capital for the green investments, and what are the consequences? Here I have the results for achieving this goal. The policy that is equivalent to the 3 SEK per ton taxation is to provide 2% subsidy for the green capital, which means that if the interest rate is 5%, then the green capital's interest rate would be 3%. which yes, we can achieve the emission goal, and probably because we are providing subsidy, total sale has increased. Firms, it's easier for them to sell, so price decrease, and we have a huge raise in the total sales. But if we include the money that we paid for the subsidy, then technically Sweden needs to provide financing from outside of Sweden to provide subsidy for the transition toward sustainable or more cleaner economy. That's why it makes it infeasible for Sweden to implement green subsidy and taxation. We can see that taxation was successful, and there is not that much cost for the emission tax rather than providing subsidy for smoothing this transition. And the main channel that I can propose for this is that it comes from the first order conditions, which we skipped during the presentation, where taxation in the first order condition comes, and I mean the effect of taxation will be amplified by the emission technology, which means that if you are polluting more, or if you have a dirty technology, then you will be taxed more. But for the subsidy in this simple framework, then the subsidy is uniform, and all the firms in the economy get the same subsidy. And that's why in this context, the emission taxation is more successful, or is efficient, and also it's feasible rather than the green subsidy. And I'm done. I don't know. I think I'm on time. And my conclusion, as I mentioned earlier, green capital is less important than brown capital. Green capital is equally important in green and brown sectors, but brown capital is harder to substitute in brown sectors. And there is a positive correlation between TFP and emission, and carbon taxation is efficient and the most powerful way for achieving the emission reductions that we want in the economy. And next steps would be the ongoing process that I have right now is that using perpetual inventory methods to estimate capital from investment rather than using investment data and use it as a proxy for the green and brown capital. And also, instead of using panel data and time series estimations, I'm trying to update the estimation process to do it repeated cross-section, and also extend the estimations up to 2020. And for the future work, probably I need to make the model dynamic and include adjustment costs for the capital and endogenous technology changes, which we discussed at the beginning, and also entry and exit of the firm, because it's possible that some companies become infeasible and they cannot produce anymore because of the taxations and all of the polluting consequences that they have. Thank you.